The key of the problem, like in the climate crisis and emergency, is of course energy, because energy is producing a lot of greenhouse gas emission, and within the energy sector, almost half of it is actually related to the production of electricity. So of course, investing more in renewables, getting that side of the system greener is really key. But as we can see here, and here the role of governance as well, a huge part of it in terms of emissions comes from industry. And sometimes this is really hard, let's say, to abate, because technologies are new, they're costly. And of course, everything goes, all the decisions goes around business and the return on investment. And at the same time, transport is also one of the key areas. And if we move on to the next slide, we see some of the challenges that and the massive changes that are required actually to move forward towards we call it net zero emission scenario. Part of the work that we're doing is actually to create scenarios and to create visions for what the future might look like, so that policymakers can actually project themselves and understand or get a vision of where this should be going and make the necessary, let's say, adjustment to get in that direction. In our scenarios and studies, for example, we see that between now and 2030, which is basically tomorrow, capacity addition should grow fourfold in terms of solar PV and wind. There should be a 80 times increase in the sales of electric cars. And at the same time, we should also reduce, let's say, our energy intensity, so increasing massively energy efficiency. And of course, these huge changes that are happening and will happen in the system, they impact heavily the electricity system. Just to give you an idea of how all these elements play together. So if we look at, let's say, a standard day, as we'll move forward with more renewable generation, we can see that there is a peak of, let's say, production in the middle of the day, which is usually not when the electricity is used. Because if we look at the home consumption curve, there is usually a peak in the morning and a huge peak in the evening. So of course, moving forward, both the production and the consumption would become more and more weather dependent. So there is a need to actually shift this peak or reduce this peak and actually match the production and the consumption. And of course, this will become more and more complex if we think about more rooftop PVs coming on board and an electrification of consumption, for example, more electric car, more electric heating, more air conditioners, more electric cooking. So all of this will impact heavily on this and increment this consumption curve. And if nothing is done, we would either have to turn on some very polluting gas plants, for example, to cover for that consumption that it's not managed by, let's say, to be covered by generation, invest heavily on batteries. Must be seen whether there is a feasibility which is economical and technical. And of course, to manage it in a better way and more efficiently, that's where digitalization comes into play. What we mean by digitalization: data gathering, analysis, and taking action based on this. It's not enough to actually install more and more renewables. It is key to be able to integrate them intelligently and effectively in the system, and that's where digitalization is needed. In terms of rooftop PV, we've seen countries where the operators who manage the grid, they don't know where this rooftop is, they don't know how to manage it. And as numbers are growing, this might become an issue rather than a solution. The more we move forward in terms of also climate change, extreme weather events, the more it becomes key also to be able to forecast more precisely and in an advanced way, what is expected, let's say, moving forward. And at the same time, as I was saying, transport will change a lot. We'll have huge masses of electric vehicles coming on board, which means that they will have to be charged. And this, of course, has to be managed smartly, because the risk is that people will all charge at the same time and the system won't be able to supply the necessary electricity to cover for that. And at the same time, of course, digitalization can offer the opportunity for more innovative business models, for new ways of doing things, in terms of public transport, in terms of peer-to-peer trading, in terms of managing energy and having more interactive devices that can provide a shift that is needed to support more carbonized energy systems. The final goal of all of this and digitalization and transition is to have environmental and climate benefits to really counteract this climate crisis that we're facing. And of course, an important message is that technologies is not to be implemented because it's fancy, because it's cool, but it has to serve a specific aim. So in this case, as I was mentioning before, digitalization could actually help to have a faster and better integration of renewables, but also to enhance energy efficiency. As we saw in the graph earlier, so it's not enough, let's say, to reduce the energy we consume, but it is key to reduce it when and where it is needed. And at the same time, digitalization can also help to improve the efficiency of the system. That means that we can optimize where we invest. We can leverage innovative business model, as I was saying, and we can actually make a more efficient use of the existing infrastructure. Because the cheapest way to do things is either to consume less or to use better what we already have. And at the same time, of course, this has positive repercussion on the reliability and resiliency of the system, faster response to extreme weather events, to potential blackouts, being able to predict where maintenance will be needed before there is an issue. And ultimately, all of this is needed to actually have more affordable energy for end consumers. Because if we don't, let's say, think strategically and at system level, the risk is that the future energy system will cost much more than today. We have seen during the current energy crisis, this is creating more energy poverty. And the risk with transition, if we don't address these issues, is that transition will be for the wealthier. One of the key roles also of policies is to ensure that these changes actually benefit everyone, and in particular, those people that are more at risk, more vulnerable in this stage. And of course, the decision that the policymakers take today will impact all the future generations.